Hello all, my name is Govind Kumar and I'm a maths teacher. So I hope you all are doing well. And today, in the previous sessions or the previous video, I have taught you about the three topics. What were the three topics? The three topics were the introduction of the trigonometry, naming the sides of a right angled triangle, and the Pythagoras theorem. Well, that all the topics form the base of a trigonometry. Okay, now in this session or this video, we are going to discuss about the application of trigonometry. Just I'll give you a few examples how we will use applied trigonometry and defining the trigonometric ratios with the numerical problems. Okay, so just let me give you an example how we will use applications of trigonometry. Well, okay. You might have seen electric poles on the roads, right? You might have seen the electrical poles on the roads. Okay. This is an electrical pole. Okay. This is an electric pole. An electric pole is erected by a metal wire. Erected means, it is made tight for conduction purpose. It is erected by a metal wire. So this is your metal wire. Okay, this is a metal wire. Okay, and this is a ground. So somewhere the metal wire erected with respect to the ground. Okay, and this is your ground. So this is an electric pole. This is a metal wire which is erected, and this is a ground. If you see carefully, isn't this? If we take electric pole as PQ, the point where the metallic wire is being erected from is R. You can see triangle PQR forms a right angle triangle. Isn't it so? Yes, it is forming a right angle triangle. So we can say triangle PQR forms a right angled triangle. Absolutely. Now what we are going to find it out. So now I'm going to introduce a new term which is called theta. Now what is meant by this theta? What is this new numerical term theta? Well, as we have alphabets in our English language, A, B, C, D, I would just like to tell you theta. Theta is again a Greek alphabet. Theta is nothing again but a Greek alphabet. What do you mean by Greek alphabet? Like we are using ABCD in our English languages, we have theta, which is a Greek alphabet. Now, when we are going to use theta? A theta, it's not a specific choice. It is only used where there is a measure of an angle involved. So theta will give you the choice. Theta is nothing but measure of an angle. Theta is nothing but the measure of an angle. Okay, measure of an angle. So in this diagram, you are able to see I have marked this point as theta. What does theta mean? See, theta means angle PRQ. So therefore, angle PRQ can simply be written as theta. Everywhere writing again angle PRQ. That means angle R itself is theta here. Angle R itself is nothing but theta. So we have now got the new term theta. So all for the trigonometric ratios we will discuss in this way. So applications of trigonometry, one I have shown you. So one more application you can see in your home. You might have been seeing the decoration whenever there is a function going on. Okay, so you call the decorators the tent persons. So how the person will tie a tent at your house? Okay, he will tie a tent. He will take a wooden block of wood. He will put it and then he will tie a rope and he will tie to the stone. So a wooden log which is supporting it, and a rope which is tied to the stone. So isn't it that wood, the rope, and the distance from wood to the stone where the rope is tied, is it forming a right angle triangle? Yes, it is exactly forming a right angled triangle. So in this, we will be discussing, in this kind of figures, we will be finding the height of the electrical poles. Okay, we will find the height of the electric poles. We'll find height, distances, and slopes. So for now, the application of trigonometry, we will have a separate chapter, but here I'm just applying where we can find what we can find using the trigonometry. We can find height, distance, and slopes by how? Using properties of triangles. Using properties of triangles. Using properties of triangles. So, in short, to say, trigonometry is a branch of mathematics which deals with the relationship between the side and angles of a right angled triangle. I repeat, trigonometry is a branch of mathematics which deals with the relationship between the sides, the angles, and the sides of a right angled triangle. So we have completed with the applications of trigonometry. Now we are going to come across a very, very interesting scenario, that is defining trigonometric ratios. Define trigonometric ratios. Okay, so let's discuss about trigonometric ratios. Well, so we are going to define trigonometric ratios. Defining trigonometric ratios. Defining trigonometric ratios. Okay, so before we start with this topic, I want to take a right angled triangle. I want to take a right angled triangle. So basically, I'll name this triangle as triangle ABC, which is right angled at B. Okay, and I'm going to take the angle as A. Okay, so let me discuss about the three basic trigonometric ratios. So first trigonometric ratio I'm taking with respect to angle A. The reference is angle A. Now let me go through it. So the first trigonometric ratio is sine of angle A. Sine of angle A, which is nothing but sine A. Okay, this is the full form. This is the short form. Sine of angle A, which is written as sine A. Obviously, S can be small, but the angle that you're writing should always be in the capital letter. And this is sine of angle A, which is nothing but sine A. So, as I told you, with respect to A, BC is the opposite sides. Let's mention the opposite sides here. With respect to angle A, BC is opposite side. Okay. AB is adjacent side, and AC is hypotenuse. AC is nothing but hypotenuse. So sine of angle A is nothing but sine A, which can be written as the formula is nothing but opposite side by hypotenuse. Opposite side by hypotenuse. So the first trigonometric ratio is nothing but sine of angle A. In short, we will write it as sine A and read it as sine A, which is nothing but opposite side by hypotenuse, which is nothing but opposite side by hypotenuse. The second trigonometric ratio is nothing but cosine of angle A. In short, we will write it as, see here what I'm underlining, cos A. The way I'm writing, this is cosine of angle A, and we will write like this and we will read it as cos A. We will read it as cos A, which is nothing but adjacent side by hypotenuse. Adjacent side by hypotenuse. The third trigonometric ratio is nothing but tangent of angle A. Tangent of angle A, which is simply written as tan A. Which is simply written as tan A. So sine of angle A, which is sine A, which is opposite side by hypotenuse. Cosine of angle A is nothing cos A, which is nothing but adjacent side by hypotenuse, and tangent of angle A is nothing but opposite side by adjacent side. Opposite side by adjacent side. Now some interesting facts we have to discuss. See, sine A. The first, when you're writing S, generally we follow a convention. S will be small and A will be capital. And it is not separate. It is sine into angle A. So it is sine A. It is sine into corresponding angle. That is sine A. This is cosine of angle A. We will read it as cosine of angle A, but we will write in short as cos A and read it as cos A. We will write like this and read it as cos A. Tangent of angle A, we will write as tan A. So you have to also be very, very particular about the way you write a particular trigonometric ratio. See, in all the concepts, I have taken A as capital. So sine A is equals to opposite side by hypotenuse, cos A is equals to adjacent side by hypotenuse, and tan A is equals to opposite side by adjacent side. Alright, now this is a formula. If I apply this to my triangle, if I apply this trigonometric ratios to my triangle, so let me see what would be the sides. Okay, now see here, opposite side is nothing but BC and hypotenuse AC. Very simple. Okay, so BC by AC is the sine of angle. Next, cosine of angle A, cos A. What is adjacent side? I have already written AB. So write the sides. AB by hypotenuse is nothing but AC. Hypotenuse is nothing but AC. Well, tangent of angle A, which is written as tan A, which is opposite side, is nothing but BC. And adjacent side is nothing but AB. So these are the basic trigonometric ratios. In order to remember, previously they have given a short, notation. We can remember these three ratios by using a short form, which is nothing but so, ka, to. So ka to. S is nothing but sine, O is nothing but opposite, H is nothing but hypotenuse, C is nothing but cos, A is nothing but adjacent, and H is nothing but hypotenuse. T is nothing but tan, O is nothing but opposite and A is nothing but adjacent. So how to remember? So, ka, to. So, ka, to. If you remember SOH, CAH, TOA, it will be easy for you to remember the angle. Once again, I repeat, S is nothing but sine, O is nothing but opposite, H is nothing but hypotenuse, C is nothing but cos, A is nothing but adjacent, H is nothing but hypotenuse, T is nothing but tan, O is nothing but opposite, A is nothing but adjacent. So, ka, to. This is the conventional method which I follow for remembering, and if you follow it properly, I think you can also remember. Otherwise, the normal way also is you can remember. These are the basic three trigonometric ratios. So just once again, I want to tell, is this end of the trigonometric ratios? No, there is not an end with the trigonometric ratios. We have reverse of this ratios, which are called, you can take multiplicative inverse of this three trigonometric ratios. Now we will discuss more trigonometric ratios, okay, which are quite opposite to this, or reverse of this trigonometric ratios. So I'll just write down here itself. So the fourth ratio is multiplicative inverse of tangent. Now we will use the word co. Remember, this word will be co. Okay, we'll use the word co. Now tangent of angle. Okay, it was tangent of angle. So what I will tell now, cotangent of angle A, which is nothing but cot A, cot A. So which can be written as C. Tan A was opposite side by adjacent. I told you it is reverse of tangent. So can you tell me it would be what? Yes, exactly, you are correct. It would be adjacent side by opposite side. So this would be adjacent side by opposite side. It is nothing but adjacent side by opposite side. It is adjacent side by opposite side. So if I write with respect to sides, what is adjacent side? AB. What is adjacent side? AB by opposite side is BC. Opposite side is BC. Okay. The fifth one, it is, okay, multiplicative inverse of cosine. Okay, which I call it secant of angle A, which is called as secant of angle A. Okay, so this is related to this. So the order, you be very careful with the orders I am following. Secant of angle A. Remember, cotangent of angle A is called as cot A. You will pronounce it as cot A. Secant of angle A, which is nothing but secant A, which is nothing but secant A. In short, many of them call it as secant A or sec A. Sec A. S-E-C-A. Secant of angle A. But I will try to pronounce it secant of angle A. So this is nothing but secant A. Okay? Which is nothing but, I told you, multiplicative inverse of cos A. It is nothing but hypotenuse by adjacent side. Hypotenuse by adjacent side, which is equals to hypotenuse. I'll take it as AC. Hypotenuse, we will take it as AC by adjacent side, we will take it as AB. Adjacent side, we will take it as AB. So the last trigonometric ratios, as you can see, sine of angle A. Okay, sine. Okay, we have taken secant of angle, secant. Okay, secant of angle A. The last one is nothing but cosecant of angle A. This is reciprocal or multiplicative inverse of sine A. So we will write it as cosecant of angle A. We can write it as Cosecant of angle A. We will not write cos because cosine is already over. So it is cosecant of angle A. This is a multiplicative inverse of sine of angle A. So cosecant of angle A, which I'll write it as cosecant A. Cosecant A. Remember, this all are small letters. All whichever underlined are all small letters. So cosecant A, I'll just write it down. This is for cosecant A. I'll put an arrow. So cosecant A is reciprocal of sine A. So I'll write it as hypotenuse by opposite side. So this is nothing but hypotenuse by opposite side. What is hypotenuse? AC. What is hypotenuse? AC, and opposite side is BC. So AC by BC. Okay. So these are the six trigonometric ratios. These are nothing but 6 trigonometric ratios. Okay, sine of angle A, sine A, which is opposite side by hypotenuse. Cosine of angle A, which is cos A, which is adjacent side by hypotenuse. Tangent of angle A, which is nothing but tan A, which is opposite side by adjacent side. Cotangent of angle A, which is cot A, which is nothing but adjacent side by opposite side. Secant of angle A, which is nothing but hypotenuse by adjacent side. And the final is nothing but cosecant A, which is nothing but hypotenuse by opposite side. This will form the base of your trigonometry. If you are able to remember this and the Pythagoras theorem, you can crack any problem. Remember, here, this is just for showing purpose. Here I have sine of angle A. Sometimes he may give you as angle theta. Sometimes he may give you as angle theta, or he may not give you this A, B, C. He may give you angle like this. He may give you the triangle and he will not give you vertex of the triangle. He won't give. But somewhere it would be marked as theta. Okay. Then your trigonometric ratios, instead of A, you can follow theta. So instead of sine A, the trigonometric ratios will become sine theta, cos theta, tan theta, correct? Instead of A. And the rest of the angles will become, okay, cot theta, secant theta, cosecant theta. Remember, this is the case when you are not given any angle. You can take angle theta and be very careful with the side. Same rules are to be followed. With respect to theta, this would be the opposite side and this would be the adjacent side. So here angle A is angle theta itself. In this diagram, angle A is angle theta itself. So sine of A you write, or you write sine theta, doesn't make any difference. Doesn't make any difference. So is it clear? So let us solve some numerical problems to understand more in detail, the trigonometric ratios. More in detail, the trigonometric ratios.